Hello, everyone, and welcome. Now, if you're planning a career in business, what we're about to cover today isn't just another math lesson. Think of this as a high-level strategy session. Together, we're going to build a foundational tool for one of the most critical tasks any business leader will ever face, finding that precise, data-driven point of maximum profit.
So let's start with the central question that keeps CEOs up at night. How do you find that perfect sweet spot for profit? I want you to really imagine this. You are the CEO. You've just launched a fantastic new product. The market loves it. Now, how many do you produce? 10,000? 100,000? A million? This can't be a decision based on a gut feeling. You need a rock-solid, data-driven model that tells you precisely where that sweet spot is, the exact production level that will make you the most money. Today, we're going to build that very model, piece by piece.
Here's our syllabus for today's lecture. First, we'll dig into that fundamental profit question. Then, we'll see why a specific mathematical curve, a parabola, is the perfect tool for the job. After that, we are going to dissect the profit formula itself. Then comes the main event, finding the point of maximum profit. We'll apply it all to a concrete example, and finally, we'll go over some common pitfalls to make sure your analysis is always spot on. You see, every single business on the planet faces this strategic challenge. It's a classic balancing act. If you produce too few items, sure, you sell out, which feels good, but you've left a massive amount of potential profit on the table. But, and this is a big but, if you produce too many, your costs for materials and storage start to balloon. You might even have to slash prices just to get rid of the excess inventory. And when that happens, your profits can actually go down. The real goal, the strategic goal, is to find that perfect balance, that peak performance point. Now, it's really tempting to think that profit is just a simple straight line. The more you sell, the more you make. Easy, right? Well, reality is, it's a lot more complex. A straight line model just doesn't work because it doesn't account for real-world constraints. It doesn't factor in things like market saturation, that point where pretty much everyone who wants your product already has one. That's why a curve, specifically a downward-facing parabola, is a much more realistic and powerful model. It shows profit rising, reaching a peak, and then, crucially, it shows profit falling if you overproduce. That's the reality of business. So what's the mathematical engine that creates this beautiful, realistic curve? It's called the quadratic function. And for our purposes in this course, we're going to call it the profit function. It looks like this. P of x equals ax squared plus bx plus c. I want you to burn this into your memory. This equation isn't just algebra, it's the blueprint for your entire profit curve. Understanding what each part of it means is absolutely non-negotiable for any serious business analyst. This is your guide. Okay, so let's pop the hood on this function. We're going to treat it not just as a piece of math, but as a financial story. Each character in this story, the A, the B, and the C, represents a very real, distinct force that's acting on your company's bottom line. So let's deconstruct it, and you'll see the business meaning behind the math come to life. Now, this is arguably the most important part of our lecture today, because it's where we translate the math into business reality. Let's take our time here. First up, let's look at C. The C term represents your fixed costs. Think of this as the money you have to spend before you sell a single thing. It's your rent, the cost of your machinery, your baseline salaries. It's your starting financial hurdle you have to overcome. Okay, next is the BX term. This is the exciting part. This represents your initial growth. B is the profit you're generating for each unit you sell at the beginning. This is what creates that steep, upward climb on your profit curve. But now, for the most critical piece for our strategic puzzle, the AX squared term. In virtually all profit models, this A value is going to be negative. Why? Well, think about it. It represents the powerful real-world forces that push back against infinite growth, things like market saturation, increased competition, and diminishing returns. It's the force of gravity on your profits, the very thing that bends the curve downwards and creates that all-important peak. Without that negative A, your profit would just go up forever, and we all know that's not how the real world works. So if our profit function creates this beautiful mountain, our mission as business strategists is clear. We need to find the absolute highest point. We need to get to the summit. And in mathematics, that peak has a very specific name, and it holds the exact answer to our fundamental business question. That peak is called the vertex. Now, for a profit function like ours, the vertex isn't just some abstract geometric point. No, it is the single most important piece of strategic information you can possibly have. Why? Because its x-coordinate, its position on the horizontal axis, tells you the exact number of units you need to produce to maximize your profit. Finding the vertex is what moves you from guessing to knowing. So how do we find this magical point? Do we have to plot millions of data points on a graph and just eyeball it? Of course not. We have a precise, powerful, and, a surprisingly simple tool. It's the vertex formula. X equals negative b divided by 2a. This beautifully elegant formula is the key that unlocks the optimal production number for any quadratic profit model you'll ever encounter.
All right, theory is fantastic, but let's get our hands dirty and make this concrete. We're now going to take everything we've just learned, the function, the meaning of its parts, and our new vertex formula, and apply it to a company's profit function to see exactly how this works in practice.
So here's our scenario. Let's say a company has done its market research, analyzed its costs, and its analysts have determined that its profit, which we'll call P of X, is modeled by this function, negative 5x squared plus 50x minus 100. Our job as consultants is to advise the CEO. What is the optimal number of units X to produce?
Okay, let's walk through this together step by step, just like you would in a report. Step 1 is simple. Identify your coefficients. We look at our function. The value that goes with x squared is a, so here a is negative 5. The value that goes with x is b, so b is a positive 50. Easy enough? Now for step 2. We bring in our tool, the vertex formula. We're going to carefully plug our values in. So x equals negative, and then our b value of 50, all divided by 2 times our a value of negative 5. Step 3. Let's calculate x. I always recommend solving the denominator first to keep things clean. So 2 times negative 5 gives us negative 10. Our equation is now x equals negative 50 divided by negative 10. A negative divided by a negative is a positive. 50 divided by 10 is 5. So we have our number, x equals 5. But, and I can't stress this enough, this is the most important part, step 4, interpret the result. What does 5 actually mean? It's not just a number. If you tell your boss the answer is 5, they'll look at you funny. It means the company will achieve its absolute maximum profit when it produces and sells exactly 5 units. Not 4, not 6, 5. That is a precise, actionable, data-driven business directive.
Now, before we wrap up, I want to give you a word of caution. As future business leaders, knowing the formula is only half the battle. In a real-world environment where millions of dollars could be on the line, a simple calculation error can lead to a disastrously wrong decision. So let's cover the most common mistakes I see students make year after year so that you can avoid them in your careers. Okay, I need everyone's full attention here. The single most common error I see semester after semester is forgetting the negative sign that is part of the vertex formula itself. It's negative b over 2a. That negative sign is there even if your b value is already positive. Don't drop it. Second, students will sometimes mix up a and b. Just remember, a always travels with the x squared term. Third, and this is a big one for your professional lives, never, ever just give the number as the answer. The answer isn't 5, it's 5 units. Context is everything in business. And finally, simple arithmetic errors in the denominator. Double-check your multiplication of 2 times a. A small slip-up there can throw your entire result off. I want to leave you with this quote from Stan Gutter, because it perfectly captures what we've tried to accomplish in our lecture today. We took a very complex, messy business problem, profit optimization, and we used the clean logical structure of mathematics to find a simple, elegant, and incredibly powerful solution. So, when all is said and done, what is the key takeaway? It's this. The mathematics we've discussed today isn't just some abstract classroom exercise. It is an essential, practical tool for high-level strategic decision-making. And mastering tools like this is what separates a manager who guesses from a leader who knows. And as you move forward in your studies and into your careers, I want you to chew on this question. We've used a parabola to find maximum profit. Okay, great. But what else could we model? Could we find a minimum cost? Could we find the optimal advertising spend to maximize customer reach? The applications are nearly endless, and that, right there, is the true power of bringing quantitative analysis into the world of business. Thank you for your time today.